ተናስተልኝ ተማሪዎች ባለፈው እንግዲህ ጥያቄ ሰጥቻችሁ ነበር የሂሳብ ጥያቄዎች 3 ጥያቄዎች ሰጥቻችሁ ነበር አብዛኞቻችሁ ጥያቄዎችን እንደሞከራችሁና ዌብሳይቱ መልስላሽ እንደሰጣችሁ አይቻለው ትክክለኛ አብዛኞቻችሁ ትክክለኛው መልስ እንዳገኛችሁ አይቻለው ስለዚህ ተሳትፏችሁ በዚሁ ይቀጥል ብዬ እላለሁ ከዛው ውስጥ አንዱን ጥያቄ ብቻ መርጬ ለዛሬ ምላሹን እሰጣለሁ ሶስተኛውን ጥያቄ ብናየው the integration of x times the square root of x dx this to find the integration of this expression by the way these two expressions can be written in a single power form so expressing in that form will integrate it look x solution for this x root x this means it is x the power of 1 times x the power of 1 over 2 therefore the product of these two is this x the power of 1 plus 1 over 2 so when you add these two you get 3 over 2 this is it therefore the integration of x root x dx this is equal to the same as the integration of x the power of 3 over 2 therefore the integral of this expression is simply this x the power of 3 over 2 plus you add 1 in the previous I think you remember the formula simply you add 1 on the power and you write this on the denominator so simply it is 3 over 2 plus 1 and don't forget the integration constant c therefore this is equal to this x the power of 3 over 2 plus 1 is simply it is 5 over 2 over this result also it is 5 over 2 plus some constant c therefore when you divide this one you can just invert or you take the reciprocal of this one to here simply it is 2 over 5 times x the power of 5 over 2 plus c so this is the correct answer so today we will proceed to another content the integration of the form x plus p the power of n okay let's see that the third point integration of the form f of x is equal to ax plus p the power of n so we need to find the integral of this expression ax plus p the power of n dx to integrate this expression I have to change this into a single variable if you change this into a single variable it becomes some power some maybe y if you say y the power of n so this it becomes power function and it can be easily integrable so to do that let us assume this expression to be ax plus b be u is equal to this ax plus b this expression we assume to be u a single variable when we change this variable into u I have to change this integration variable into u so to do that let's take or let's differentiate this expression in terms of x that means this d by dx of u is equal to d by dx of ax plus b the derivative of this one is this du by dx this equal to the derivative of this expression with respect to x is simple, it is a. This is it. From this expression, I can solve for dx. Simply interchange these two. Therefore, dx, this is equal to this du over a. So, in this procedure, we have changed x plus b to u and dx to du over a. So let's substitute these two expressions in the original integral. So this becomes, the integral of the equation is this ax plus b the power of n dx. So this is equal to, in place of x plus b, we substitute u. In the place of dx, we substitute du over a. Du over a. So I can factor, by the way, 1 over a out of the integral sign. We have seen this in last discussion, or in previous discussion. So let's put out this in front of the integral sign. So this is 1 over a times the integral of u d, u the power of n, I forgot n here, u the power of n, u the power of n du. Therefore, this equal to, it is 1 over a times, now it is becomes simple to integrate this expression because it is a power function, u the power of n du, simply x the power of n dx. So to integrate this expression, u the power of n plus 1 over n plus 1, and don't forget this integral constant c. But here, this is not our final answer. Our answer must be in terms of variable x. We got in terms of variable u, so I have to substitute the value of u. So the value, or the integration of this expression, is 1 over a times u is, it is ax plus b, ax plus b the power of n plus 1 divided by n plus 1 plus c. So this is the answer for the integration of this expression. So the integration of x plus b the power of n dx is equal to this 1 over a times ax plus b the power of n plus 1 over n plus 1 plus c. This is the final answer for the integration of this expression, the integration of ax plus b the power of n. So this is a general formula. Now let's see example for the additional example for this. Examples. Try to answer the following question. The first one is the integration of 3x minus 2 the power of 5 dx. Try to find the integral of this expression. I'll give you 1 minute for this to try. Integration of 3x minus 2 the power of 5 dx. By the way, you can use the formula, general formula, to integrate this. We put the general formula to remind you. We say it's the integration of ax plus b the power of n. This is equal to, simply it is 1 over a. You take the coefficient of x to be, you take the reciprocal of the coefficient of a, and then simply, as usual, simply x plus b the power of n plus 1 over n plus 1, and you put constant c. I hope you tried the question. So let's do it together. Solution for this, the integration of 3x minus 2 the power of 5 dx, this is equal to, this is a power function expression. As we can use this formula. In this case, a is 3, so take the reciprocal of 3, it is 1 over 3 times, simply take this one, 3x minus 2 the power of 5 plus 1 over 5 plus 1 plus some constant c. Don't forget c, integration constant. Therefore, 1 over 3 times this as it is 3x minus 2 the power of 6 over 6 plus some constant c. I can multiply this 1 over 3 by this one. You get 3x minus 2 the power of 6 over 3 times 6 is 18 plus some constant c. So this is the correct answer. Now, to practice, let's add one more example. Let's see one more example. Example 2. The integration of 3x minus 2 times the square root of 3x minus 2 dx. To evaluate the integral of this expression, I have to write this expression in a power form where the single term is 3x minus 2. We have two terms, so I have to write in single term form. So to do that, 3x minus 2 times the square root of 3x minus 2, this is equal to simply 3x minus 2 the power of 1 times 3x minus 2 the power of 1 over 2. When you change this squared expression in power form, it becomes this. So when you multiply these two expressions, since they have the same base, you add their exponent. So this is equal to this 3x minus 2 the power of 1 plus 1 over 2. So this is equal to this 3x minus 2 the power of 1 plus 1 over 2 is 3 over 2. So the integration of this expression means the integration of this one. Therefore, the integration of 3x minus 2 the power of 3 over 2 dx is equal to, remember, I changed this expression, I changed this expression by this one since they are equivalent. Therefore, the integration of this expression means the integration of 3x minus 2 the power of 3 over 2. To integrate this, we use the previous formula. Therefore, don't forget the coefficient of the x is 3. So take the reciprocal of it, and then 3x minus 2 the power of 3 over 2, add 1 on this, and write this power on the denominator. So that's it. Therefore, this becomes 1 over 3 times 3x minus 2 the power of 3 over 2 plus 1 is this, is 5 over 2. This is 5 over 2 divided by 5 over 2 plus c here. Don't forget the integration constant. So this is equal to this 1 over 3 times, take the reciprocal of this expression here, 2 over 5 times 3x minus 2 the power of 5 over 2 plus some constant c, and finally the product of this is 2 over 15 2 over 15 times 3x minus 2 the power of 5 over 2 plus c. So this is the final answer for the integration of this expression. Okay. Okay, dear students, I think these two examples will be enough for you. So using this example, it's better to do additional exercises and questions on your textbook. So now I'll proceed to integration of exponential or exponential function. Yeah, let's see integration of exponential function. Okay, let's start from integration of e raised to x. E raised to x dx. Okay, if you remember, in chapter 3, the derivative of e raised to x is this e raised to x itself. And so, from this, the reverse process, the antiderivative of this expression also, it is e raised to x only. You add the constant c. So, it's easy to remember the integration of e raised to x itself, e raised to x. There is one joke about this one. In the class, while a teacher teaches, a student disturbed the class, and the teacher said, "Please be careful. I will either integrate you or differentiate you." And then the student replied, "You can't differentiate me and integrate me. I am e raised to x," he said. So simply no change, that means. So don't forget this one, it's easily to remember. So the integration of e raised to x dx simply is e raised to x itself, but we have the constant integration c. Now let's add other form of integration of power function b, form integration of e raised to ax plus b dx, the integration of this form. So what will be the answer? To do the answer, I have to change this ax plus b into one variable as earlier. So let's assume solution for this. So let's assume u to be ax plus b. Assume this variable to be single variable u. So we have changed u, so we are integrating e raised to u, but we have the variable dx, integration variable dx. So I have to convert to the variable integration to du. So to do that, let's derive this one by variable x. That means this d by dx of function u, this equal to d by dx of this ax plus b. So this one is this du by dx, and this one, as we said earlier, it is a. Therefore, I can solve dx from this expression. Dx becomes it is du over a. So let's substitute these two expressions in this integral and then evaluate the answer. So the integration of e raised to, in place of x plus b, we use u times dx, in place of dx, du over a. Du over a. So this will be, I can factor out 1 over a from the integral sign because it is constant. So it's 1 over a times the integration of e raised to u du. So this is easily computed because we know it. Simply it is integration of e raised to x dx form, therefore itself. So the integration of e raised to u is, it is e raised to u. And don't forget the integration constant c. But our answer, as you see, it is in variable u. So I have to convert in variable x by substituting the value of u. Therefore, 1 over a times e raised to u is simply it is ax plus b plus c. So this is the final answer for the integration of e raised to x plus b dx. Now, to practice this formula, let me give you one or maybe two examples. Let's see that. Examples. 1. Evaluate the following integral. The first one, the integration of e raised to 4x minus 5 dx. The integration of this expression, simply using the formula we derived earlier, that means the integration, let me put it again here, the integration of e raised to ax plus b dx. We said this one is 1 over a times the integration of ax plus b. So using that formula, simply by the way itself, but you take the reciprocal in front of it. So the integration of e raised to 4x minus 5, this it is. The integration of, simply it is, you take the reciprocal of this one, 1 over 4 times itself, simply it is e raised to 4x minus 5, and don't forget the integration constant. So this is it. Now let's try this one. The integration of e raised to minus x dx. The integration of e raised to minus x dx. I hope this one is simple. The integration of this expression itself, but you put something in front of it. That means it is e raised to minus x. The thing you put in front of it is the reciprocal of the coefficient of x. That is minus 1. That means simply it is minus. The reciprocal of minus 1 is minus 1 itself. So it's minus e raised to minus x. So don't forget integration constant c. So this is the integration of e raised to x. Now, other form of integration of exponential function is the integration of a the power of x. Integration of f of x is equal to this a the power of x. That means this the integration of a the power of x dx. What will be the integral of this expression? Okay, to do or to integrate this expression, let me remind you the derivative of this expression. Let's do it together.